Good morning. Myself Dr. B. Jyothi, working as an Assistant Professor of Physics, Department of Freshman and BSH in B.V. Raj Institute of Technology, Narsapur. Our course name is Applied Physics. Today's topic name is Origin of Energy Bands and Classification of Solids. Let us discuss about the origin of energy band formation in solids. How the energy band form in the solids. So what is the origin of these energy bands? So let us look at this. So we know that when two atoms are equal energy levels, let us consider two atoms having equal energy levels are brought close together, the original levels E1 and E2. The original levels E1 and E2. Let us consider the two atoms having equal energies, the original energy levels E1 and E2. So each into two energy levels, each atoms having energy levels, two equal energy levels, that is K shell and L shell. K shell and L shell. So each atom, here we are considering two atoms, each atoms which is split into two energy levels, the two shells, that is K shell and L shell. So if you consider the K shell, so that is E11, E12. Similarly, the L shell, the energy is E2, split into E2 dash, E21 and E22. Okay, so let us consider two atoms here. Each atom has two shells, that is K shell and L shell. So these two atoms have equal energy, which is split into two shells, that is K shell and L shell. So means this each atom having two energy levels, that is E11, E21. So let us take second atom. It has first K shell and L shell. It has some energy, that is E12, E22, which is represent the first atom. This is the second atom energy levels. So like that, let we consider more than two atoms. So which is now when three atoms brought close together. So in the place we are taking three atoms close together, the original energy levels E1 and E2 split each into three energy levels E11, E12, E13, E21, E22, E23. So each atom which is consisting of two shells. So if you consider the three atoms, the energy levels are divided into three. So respectively like that. So then these type of transformation from the original levels into two or more energy levels is known as energy level splitting. If you consider two atoms, the energy levels are split into two atoms, two energy levels. If you consider three atoms, so each cell which is split into three energy levels. Like that, it is going process. It is going process. So then this type of splitting is called energy level splitting. So how the energy bands form? So therefore, if n number of atoms having equal energy levels are brought close together to form a solid, then it forms a closely spaced continuous energy level, so called energy band. So what is energy band here? If you consider more than two atoms, means if you consider n number of atoms which are brought close together, so which is closely packed, closely spaced continuously energy levels, in this n number of atoms. So it forms some band, that is energy band. that is energy band. Means if you take two atoms, so the energy level we can see, that is when we are seeing in the magnifying view, it consisting of two energy levels. So if you considering 3 atoms, it consisting of 3 energy levels. Like that, if you considering n number of atoms, then n number of atoms which are brought close together, it forms more than it consisting of number of energy levels which are occupied in a closely spaced continuous energy levels is called energy band. So energy band is nothing but it is a number of energy levels which are continuously closed space. Which are continuously closed space. Hence, an energy band can be defined as, how to define the energy band? The range of energies possessed by electron. The range of energy possessed by an electron in a solid is called energy band. So let us consider the magnified view of the energy band, which consisting of a large number of very closed spaced energy level. So that is shown in the figure. So let us look at into this figure. So here when we talk about the energy band, we know that it has a large number of very closely spaced energy levels are available. So let us look at into the magnifying view of this energy band. So if you look at this energy band, it is some energy band is a black portion. So in between the black and in between two black portion, so it has some white space is there, that is a band gap. So whatever this black one is energy band. So when we are observe this, suppose it is the energy band. This is the energy band. This is the band gap. The band gap between the two energy bands. Energy band. So this energy band, when we are look at into the energy band. So when we are by using some magnifying lens, so it consisting of very closely spaced energy levels. So this closely spaced energy levels form a energy band. So during the formation of the energy band, the inner filled energy levels forms a energy band. Forms a energy band called inner filled band. When it is formation of this energy bands, so first it form a inner filled energy band will form. So after that, the electrons in the outermost, first is inner filled band will be formed. After, the electrons in the outermost orbits and outermost shell of atoms forms a energy band is called valency band. Will be completely filled or partially filled, that is depends on the type of a material. Okay, and if the electrons comes out from the valency band, comes out from the valency band, suppose it is a valency band, comes out from the valency band for a conduction, it forms some electrons are moving from the valence band to the another band for conduction. It forms some band, that is the conduction band. Okay, so first inner filled band will be formed. After that, outermost shells of the atoms forms a energy band. After that, outermost shell forms a band is called valency band. So for conduction, the valence electrons which are moving from this valency band to the another energy level, so which is corresponding to some energy is called conduction band. So this lower band is valency band, the upper band is conduction band. What is a forbidden band gap? So while referring the energy bands, when we are referring the energy bands, they are separated by small regions which does not allow the energy levels. So this is a conduction band and the valency band. So for conduction, the electrons are moved from the valence band to the conduction band. Sometimes which does not allow the energy levels. Some electrons are occupied in this only. So some gap will be available in between the conduction band and the valency band is called forbidden band. So let us look into the definition. So while referring to the energy band, they are separated by the small regions which does not allow the energy levels. Such region in between the energy bands are called forbidden band gap. So means what they are trying to say this. So the conduction band, the valency band, these are the energy bands. So in between the energy band gap, some not allowed energy levels are there. That not allowed energy level is called forbidden band gap. So the forbidden band gap which is located in between the conduction band and the valency band. So if you see here, conduction band is upper band, lower band is the valency band. So first it is filled, that is initially it is filled by the inner band, that is inner filled band. So after conduction, it going to the some band is a conduction band. So for this process, some space, some region which is not allowed the energy levels, that is the forbidden band gap. So that where it is located, ma? So this is located in between the conduction band and the valence band. Next, classification of materials. So we know that classification of the materials into metals, semiconductors and the insulators. Let us discuss about the classification of the solids or classification of the materials. So we know very well, so we know the three materials, that is metals, semiconductors and insulators. Let us discuss about the metals. What is metal? What is conductors? Based on the energy band gap, based on the forbidden band gap only, we are discussed these materials, the metals, semiconductor or insulator. So in conductors, there is no forbidden band gap. There is no forbidden band gap. Here the valency band and the conduction band overlap each other. So look into this figure. So this is a valency band and this is a conduction band. So in these conductors or metals, the forbidden band gap, where it is forbidden band gap is there? The forbidden band gap is between conduction band and the valency band. Valency band or conduction band. Valency band and conduction band. Where is the forbidden band gap in the conductors? The valence band and the conduction band overlap each other. There is no forbidden band gap in between in the metals or conductors. So in metals, the availability of free electrons will be very high due to the overlapping of conduction band and the valency band. So hence, even when small external field is applied to this, the electrons from the valency band to the conduction band freely enter. The electrons from the valence band to the conduction band is very freely. So to produce the current. So means for producing the current, less amount of the external field is required for the metal or conductor. Because of there is forbidden band gap is not there, means the valency band and the conduction band is overlap each other. What are the example for the conductors or metals? Copper, aluminium, iron, etc. So this is a diagram for the metals. So here the overlapping is there. Okay. So there is no forbidden band gap in the metals. Coming to the semiconductor. In the name itself only semiconductor. Semi means off. So sometimes it behave as a conductor, sometimes it behave as a insulators. So let us look at into the definition of the semiconductor. In semiconductor, the forbidden band gap is very small, in the order of 0.5 electron volts to the 1.5 electron volts. In semiconductor, the forbidden band gap is very small, that is about 0.5 to 1.5 electron volts. Hence there will be a very small gap between the valency band and the conduction band. Hence, there will be a very small gap between valency band and the conduction band. So, let us look at into this figure. So, the semiconductor diagram, so that is energy. So, here the field energy band, it forms some inner field energy band, after that valency band, after that conduction band. So, the in between the forbidden band gap will be there, means here it does not allow the energy levels. So this is a forbidden band gap. So this is about 0.5 electron volts to the 1.5 electron volts in a forbidden band gap in between the conduction band and the valency band. So this is a semiconductor. What are the best examples of the semiconductor is germanium and the silicon. Examples of the semiconductor is germanium and the silicon. Coming to the insulator. So, what is an insulator? Means here when we talk about the insulator based on the forbidden band gap, the forbidden band gap is very wide, means very large. The forbidden band gap is very large, that is the range is 3 electron volts to the 5 electron volts. 3 electron volts to the 5 electron volts. So, there will be a very large gap between the valency band and the conduction band. Valency band and the conduction band as shown in the figure. Since the forbidden band gap is very high, in case of insulator, very large amount of energy is required to produce the conduction or produce the electric current in the insulators. So, a very large amount of energy is required for the conduction to occur. For conduction to occur means very large amount of energy is required to produce the electric current. Okay. So, in this insulator, the forbidden band gap is very high. In between, forbidden band gap is very high is nothing but the band gap between the conduction band and the valency band is very high. That is about the 3 electron volts to the 5 electron volts. So, because of this high or very large forbidden band gap, so we should apply large amount of applied field. So, for producing the conduction of electrons. So, what are the examples of the insulator is diamond and dielectrics. So, this is the figure for the insulator, that is forbidden gap is 3 electron volts to the 5 electron volts. So, the forbidden band gap will be very high when we compare to the semiconductors. So, this is the insulators. So, this is the concept of the classification of the materials into metals, semiconductors and the insulators. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.